Well, I'm joined by Cavosie, who is a planetary scientist in the Space Science and Technology Centre at Curtin University. Welcome to the programme. So this sounds like a close shave, was it?
Thanks for having me, Sally. This was close, but not a cause for alarm. This is an object that had been tracked by scientists for 20 years. And so a lot was actually known about it. If it was much closer, there would have been another plan of action.
So just tell us a bit about this asteroid then. What do we know?
Well, the NASA Infrared Telescope facility in Hawaii has been collecting spectral data from this rock, and those data indicate that it's probably a stony asteroid rather than an iron asteroid. So that's one piece that's interesting. During its passage near Earth today, the Deep Space Network, part of which is located in Australia, will actually do some radar studies of its surface as well. And the neat thing about that is they'll be able to test the idea on whether or not it has a moon that orbits it as well. So they'll be able to find out things like that that are interesting. I mean, listen, this rock's been sitting in the deep freeze for 4.5 billion years since the beginning of the solar system. So when they come this close, it's a real opportunity to learn some neat science.
Yeah, I can imagine. I'm sure it's absolutely fascinating. But in terms of you saying there would have been a plan if it was a threat to Earth, what is that plan?
Well, in terms of mitigation for something headed straight at Earth, those kinds of plans are still in the works. There's a lot of mitigation strategies. I'm not going to speak to those today, but the key observation here is that this particular event was not a threat. There's no indication that this rock will be a threat for the next several hundred years. So we're in the clear about that. The deal with this one is that the faster an asteroid travels, the more energy it creates during an impact. In this case, this one is actually traveling pretty fast, about 35 kilometers per second, which is, as far as space rocks go, quite fast, although comets can travel even faster than that. So, but even with that great speed and with its significant size of the object, this one wasn't a threat. At its closest, it'll be about 2 million kilometers from Earth. And that might not sound like a lot, but that's still 5 times further away than the moon. So we're in the clear.
If it were to hit the Earth, though, what would the impact be?
Well, that's actually what I study more, impact craters. Earth does get hit on occasion. There's no doubt about that. If this rock would have slammed into the Earth, it would have been an event felt all around the planet. To put it in perspective, this rock was only about 5% the size of the one that killed the dinosaurs 65 million years ago. So it was small on that scale, but still it was 10 times larger than the one that created a meteor crater in Arizona. And so it would have left a pretty significant impact. The size of the hole in the ground it would have left is something on the order of about 5 kilometers. And that doesn't sound very big. But if you think about it, 5 kilometers takes out Manhattan, does a good job on Perth. And I hate to say it, but even London's not going to have a good day with a 5-kilometer hole in the ground.
Gosh, Aaron, it's scary stuff. But I'm going to have to call you to a halt here, I'm afraid. We've got more to do. Yeah, go on.
Nothing to worry about for this one. Thanks for having me on.
It's been good to talk to you. Thank you so much. Fascinating.
Cheers,
absolutely
Sally.
Fascinating. Thank you.